Hi everybody, welcome back to videos. This is Unit 5, Lesson 1, and it's Section 1 of your notes, and we're going to be talking all about naming binary compounds in this section. And so we first have to define what a binary compound is. And binary compounds are those that contain only two elements. So no more, no less, two elements. And you can tell if you have only two elements because you'll only have two capital letters in your formula. So some examples of binary compounds include our dihydrogen monoxide, right? Two capital letters. Or our sodium chloride, two capital letters. Or carbon dioxide, only two capital letters. Okay? Things that are not binary compounds are things that don't have two capital letters, like O2. That's just elemental oxygen, okay? Or KNO3, that's potassium nitrate. That has 1, 2, 3 capital letters. So these things are not binary. So we're going to name binary compounds. You first have to identify you have a binary compound if there are two capital letters. And there's different ways to name binary compounds depending on what types of elements are present. And so you're going to look at the elements in your binary compound. For example, H2O, H is a nonmetal, oxygen is a nonmetal. So we're going to name that one way. This is called a covalent compound. And we're going to use one set of rules to name it. Whereas NaCl is a metal to a nonmetal, that's called an ionic compound, and we're going to use a different set of rules to name it. So you want to identify what you have in your binary compound first. So this is the next page in your notes, and you have the rules here. And I figured we'd walk through these rules with examples. That's probably the best way to do these. So I'm going to put this so that we have this page in front of us. I know it's kind of small. Let me enlarge it a little bit here. Okay? And let's take a look at the first example. The first examples we have here in your notes, and these are on the next page of your notes, I believe. So find these examples, is SF6. So you want to look at their location on the periodic table, right? Sulfur's over here and fluorine's over here. So remember the staircase separates us. These are our nonmetals this way, and these are our metals this way. So both sulfur and fluorine are to the right of the stairs. They're both nonmetals. So this is nonmetal to nonmetal. So we're going to use these rules to name them. So sulfur, nonmetal to nonmetal, right up here. We're going to use this set of rules. And rule number 1 says write the name of the first element. So that's sulfur. Rule number 2 says if the first element has a subscript other than 1, use the chart below to determine its prefix. Well, sulfur doesn't have a subscript other than 1, so we can ignore that. Number 3 says write the name of the second element, fluorine. Drop the ending. Now, normally you go 2 vowels in, drop the ending and add I-D-E. This is sulfur fluoride. And then use the chart below to determine the prefix of the second element. The second element always gets a prefix. So fluorine has a subscript of 6. So on our chart here, we'll go to 6, and 6 is hexa. So this is going to be sulfur hexafluoride. I'm just going to rewrite that because it's kind of a mess. Sulfur hexafluoride. Okay? Let's do one more of those examples. Okay? Again, binary compound, 2 capital letters. Let's look up the location of P and O on the periodic table. P is here, O is here, so these are also both nonmetals. So we're going to use the same rules that we just used. This is nonmetal to nonmetal. So we named the first element, phosphorus. We look at the subscript, it's a 2, so we use our chart over here, okay, to write that prefix in front of phosphorus. 2 is diphosphorus. We name our second element oxygen, okay? We go 2 vowels in, the Y counts as a vowel, and we drop the ending and add IDE. So this is diphosphorus oxide. We look at the subscript, that little number for oxygen. It's a 5. So this is diphosphorus pentaoxide, okay? And we could, of course, rewrite that. All right, I would like you to try this one and this one for tomorrow, okay? So have those done when you come in. I'm going to be checking those. Let's take a look at the other thing. What if it's not 2 nonmetals, but it's a metal and a nonmetal, okay? So let's take a look at those. Again, I just have these rules up here so we can follow them a little bit easier. So we're going to be now looking at this type of compound, where now we have in our binary compound not a metal, not 2 nonmetals, but we have a metal. Oh, can I make that bigger? Come on. There we go. I want to just make these examples a little bit bigger here for you. Oh boy, I don't know what I did. Let's pause. Okay, sorry, I had to fix that a little bit. Now I'm back. It's a little bit bigger so you could read it. So if you look at your examples here, okay, and you look your elements up on the periodic table, the first element was Ca. See, that's to the left of the stairs. And the next element is chlorine. So now we have a metal and a nonmetal present in our compound. And we have a different set of rules to name them. Mind you, we don't use those prefixes. So let's look at these rules over here to name them. First of all, name your metal. So we get the name of the metal off the periodic table. It's calcium. Here's what's different. We have to look up the number of charges the metal has in its box. So if we go to calcium and we look here, I know it's very hard for you to see because I'm zoomed in quite a bit. There's only 1 charge in the box. It can only be +2, okay? Contrast that to like vanadium here, where there's multiple charges in the box. So if there is only 1 charge in the box, number 3, name the nonmetal, drop the ending, and add IDE. So this would normally be chlorine. We drop the ending, 2 vowels in, and add chloride. And that's it. You're done. You do not use prefixes. That's very important. There's no prefixes at all used when it's a metal to a nonmetal, okay? So when there's only 1 charge in the box for the metal, you name the metal, name the nonmetal, drop the ending, and add IDE, and you're done, okay? But what if, look at number 4, what if there's more than 1 charge? Well, then you have to calculate what charge your metal has and put it in Roman numerals in parentheses after the name of your metal. So let's try a couple of those, and we'll do a couple more examples with this because it's a little bit more complicated. So look at the next one, CuCl2. So again, we figure out, do we have 2 nonmetals, a metal and a nonmetal? What do we got going on? So here's copper, right? Here's chlorine over here. You can barely see it, but either way, you can see we have things from different sides of the stairs. We have a metal to a nonmetal. So as rule number 1 says, we name our metal copper. We go look up our metal and see how many charges are in its box. Now, copper has more than 1 charge, which means we're going to need parentheses and Roman numerals after its name. Let's name our nonmetal, drop the ending, and add IDE again. And now we have to figure out what copper's charge is. So we have CuCl2. We need to know what charge we're using on copper. That's an X up there, okay? If you take a look here, this is in your notes as well. Here's some tips for calculating the charge. The metal will always have a positive charge. The nonmetal, so this is your metal, right? This is your nonmetal. This will always be positive, chlorine will always be negative. So to figure out what copper is, you're going to go look up chlorine and pick the negative charge that chlorine has in its box. Okay, again, I don't know why my thingy's not erasing here, but if you look for chlorine, let me. Okay, sorry, I'm back. If you look for chlorine here, there's a whole bunch of charges, but there's only one negative charge in its box, and that's the one we're going to use. So he gets a -1 charge. Now, here's what's key. The total charge, the subscript times the charge plus the subscript times the charge must always equal 0. And here's what that means. Copper, there's only one of. So bottom times top, 1x. Bottom times top, -2, always has to equal 0. So if you solve for x, x is going to be 2, and that goes in here in Roman numerals. Okay? 2, if you don't know your Roman numerals, I have them over here for you in your notes. Okay, I'm back. Sorry for that brief delay. We'll try a couple more of these. Let's take a look at this next one here. I mean, clearly we know Mg is to the left of the stairs. It's a metal. This is a non-metal. So, rule number 1, we name our metal magnesium. Whenever you have a metal first, you have to go look it up on the periodic table and see how many charges are in the box. So if we look in magnesium's box, it only has one possible charge. So if there's only one possible charge right here, if there's only one charge, we name our nonmetal phosphorus. Drop the ending, 2 vowels in usually, and add ID. So that's magnesium phosphide, right? I like to have it next. Magnesium phosphide. And that's it, you're done. No prefixes, no Roman numerals. Okay? That's it. So if your metal only has one charge in the box, that's all you need to do. Take a look at this next one. Iron is a metal, oxygen's a non-metal. Okay? Again, I'm using that in the periodic table. Iron's to the left of the stairs, oxygen's to the right of the stairs. For the record, you'll never have a metal-metal compound. Metals can't make each other happy. So you'll have non-metal to non-metal or metal to non-metal. So we name our metal iron, and then we go and look up how many charges it has in the box. There's more than one charge in the box. So when there's more than one charge, you add the parentheses after the name. Then you name the nonmetal, drop the ending, and add IDE. By now, you're recognizing that all binary compounds will end, whether they're nonmetal or metal nonmetal, they'll end in IDE. Now, the thing that's different about this is when there's more than one charge in the box, you have to figure out which one iron has. So you go to oxygen and look up its charge in the box. And oxygen is -2. Remember, your metal is always positive and your non-metal is always negative. This is -2. Okay? And then the sum of all the atoms and their charges must be 0. So we look at the subscript for iron. There's no number written there, so there's 1, and we do bottom times top, 1x. We look at the subscript for oxygen. There's 1. Bottom times top, that has to equal 0. So x is iron's charge is 2. So that number goes inside those parentheses in Roman numerals. Okay? This is iron, Roman numeral 2, Xi. I'd like you to finish these up. Try these ones, please, for homework on your own. And then when you come in tomorrow, you'll get your test back, and we'll check these over, and you'll do a little bit more practice with this. Have a great night, everybody. Bye-bye.